Hey everybody. All right. This is going to be a BGP lab, specifically eBGP. Let's walk through here. All right. So we got router 1, router 2, router 3. All right. Before we get into the nitty-gritty of eBGP. Not nitty-gritty, but it's a basic configuration, but you need to understand a couple things. So what do we got here? This is the 10115 interface, and it has a loopback, this router of 1111. This is router 2, which has, let me show protocols again. Go here. Show protocols. All right, so this is the 10119, which is this interface right here, G00. 10116, which is this interface, this interface right here. And then the loopback is 222. We're using a 32-bit mask. Standard 30s on the other one. All right. And then lastly, protocols. And I like doing this command, not instead of show IP in brief. You're going to take a look at a real quick peek. You can do a show IP in brief, up, down, all that. But this is the sister, the brother, the cousin, whatever you want to call it. Show protocols. I like it because it gives you the subnet mask on top of that. All right, show IP in brief doesn't do that. All right, it tells you that it's up, administratively down, whatever the case be, up, that's what you need. So this is the 10 right here, and this is the loopback for this router. Cool. Now we know our topology. So eBGP. eBGP, or BGP itself, Border Gateway Protocol, is an exterior gateway protocol. All right. It's mainly used to take people out onto the internet, right? So you've heard of your customer edge routers and your provider edge routers. Some companies get BGP to get out to the internet, or they want to do policy-based routing, meaning they want to go ahead and have control of policies that they're going to implement for their networks, right? Medium-sized enterprise networks, they do this. Obviously, ISPs do this. This is the protocol of the internet, all right? The version is 4. But it has a lot of quirks, okay? It has a lot of nuances. BGP. All right, there's 2 types. You got eBGP, which we're going to do, and you have iBGP. eBGP, meaning they have different autonomous systems. They do have eBGP runs on autonomous systems. Now, they have public and private autonomous systems. I'm not going to get deep into that just yet. But they do run, you cannot run, if you're going to run a public autonomous system, it better be assigned by the IANA or an ISP or some sort of provider, third-party provider, whatever it is. You cannot just get any public ASA and decide to go with it. Can't do that. You're going to cause issues online. So, if anything, you run a private ASN. I'm sorry. Oh my God. Autonomous system number. All right. That's what you would run. With BGP, that means you have different autonomous system numbers. Router 1 will have, let's say, 100, which is not the one, right? Let's say 65-100 would be router 1, 65-200 would be router 2, 65-300 would be router 3, as an example. That's what they really look like, okay? Or more or less, what they look like. So you'll be running those, right? Those will be eBGP. And the thing with eBGP is that you're going through multiple autonomous systems. Therefore, you're going to have what's called an attribute of BGP. We'll get into that later. You got path attributes, which is called the autonomous system path length, right? And BGP goes through a little circus, a little circus of seeing which one is the best path. But we'll look at that in a second. And just so you know, say straight off the bat, BGP is called a routing protocol. It is not a routing protocol. It is an application or control plane protocol. Okay? It's not. It doesn't have the entire view of the topology. Okay? So it's not. It uses TCP port 179. So just basics, throwing it out there. It is not a routing protocol. It runs at layer 7. Okay? It runs at layer 7. So let's start configuring. Let's go to router 1. It's very simple to do. And as we do this, I'll go ahead and tell you what's up. So the IP's already in there, so that's fine. Config T. So we're going to do router, BGP. Let's do 65-100. That's this. You just enabled BGP, this autonomous system. You cannot add another autonomous system to this particular router. Okay? Now, there is something that you should do, BGP router ID. You should put it, identifies the router. You should put one in manually, not just whatever. You should put one in. It identifies the router, because if you do one later, it'll reset your interfaces. It'll come down, it'll come up again. So let's do it manually, 192.168.1.1, right? That's router 1. Okay, so what we do, there's no hellos. So what we do is we tell explicitly who our neighbor is. So we say neighbor 10.1.1.6. And then we tell, okay, what remote AS is that neighbor in? Well, he's in 65.200. Okay? But now, if it will be, let's say, iBGP, and I will put 65.100, that's fine. You still need to put the command, remote AS. That's just the syntax. You got to do it. Okay? And that's it, really. Now, well, I'm not going to show you this yet. I'm just going to do that portion of it, and we'll come back and do the other part. All right? So this is what we're doing right now, called peering, creating a BGP session. In this case, it will be an eBGP session. All right? Do WR. All right? So this is going to be now router BGP 65.200. All right, let's do the router ID. Ooh, okay, router ID. This is 192.168.2.2. Give me whatever. I mean, you can put whatever you want. I just put that in there. And then we're going to peer. Now we got two neighbors, one going to either side. So let's go back. All right, so we're going to do neighbor is 10.1.1.5, and his remote AS is 65.100. Now when I hit enter, CML is pretty quick when it comes to do this. Generally takes forever, at least on mine it does. You need to see an up, like the neighbor is up. Okay, so we hit enter. All right, and now we need to do the other neighbor, which is router 3. Neighbor 10.1.1.10 remote AS 65.300. Nothing's going to come up because there's nothing configured on router 3, so it's not going to come up. And again, all we're doing right now is just sessions, peering. That's all we're doing is peering. All right, and then we're going to do config T for router 3, router BGP 65.300. Okay, BGP router ID. Okay, and this is 192.168.3.3. All right, and let's do neighbor. That's 10.1.1.9 going back to router 2, and then his remote AS. And this should come up quicker, I hope. 65.200, maybe not. Oh, okay, cool. A little quicker, Now, if you were to look at this, and just look at it, let's go back to router 1 and take a look at it there. All right, Control Z. There's two commands, show IP BGP. You see nothing. Show IP BGP summary. Right, because show IP BGP shows you your BGP table, okay, or your local RIB. So you didn't create any BGP tables, because in order to create a local RIB, you need to do network statements. So right now, what do we have here? This is our neighbor, right? That's our IP address of our neighbor. This is version 4, BGP version 4. This is the autonomous system of our neighbor. I've received 5 messages from my neighbor, and I've sent my neighbor 5 messages. The table version that I've received from my neighbor from the last update is table version 1. Okay, how long have it been up or down? 1 minute and 17 seconds. And you can see 0 here. I haven't received any prefix received, because I am not sending any advertisement out. I have not typed the network command, right? So I haven't sent anything to advertise. Now here, this is crucial right here. You want to see at least a 0. If you're doing the network command, you want to see 1, 2, 3, 4, whatever it is, but you need to see something here. If you see nothing here, that's an issue, or NA or something like that. Under the state, also, you want to see nothing. You want to see anything under the state. Because if you see something under the state, there's something wrong. So you don't want to see anything under the state. Okay? All right. So can we ping across? Right? On 10.1.1.9. Can't ping. We're not routing. Right? We just peered. So you can see it's not routing. Okay, now we can route with BGP if we wanted to, but again, careful when doing that. But we're going to go ahead and do that in this particular lab. Config T. This is router 1. We'll do router BGP to go back in. BGP 65.100. Now we're going to use the network command. Network. What networks am I attached to? So I'm attached to the 10.1.1.4 that has a mask of 255.255.255.252. Okay. I also have a loopback network that's 192.168.1.1 with a mask of 255.255.255. Okay. Dot 255. That's a 32-bit mask. So these are the two networks that I'm attached to. All right, cool. Let's go to the router 2. All right, let's do we're in there already, so let's do show protocols just to make sure before we start configuring. We're already inside the autonomous system, so we'll need to type it. Do show protocols. Okay, so 32-bit. No, is it a 32? Why? Oh, look, we did a loopback. Yeah, but it's 2. So this is wrong. That's the router ID. Duh. So we say no, and in CML2, you have to copy, literally copy, and then paste. That's wrong. It should be network 1.1.1.1, 255, 255, 255, 255. 192.168.1.1 is the router ID, not a network that I'm attached to. Oh, forgot the word mask. There we go. Now we're good. Now we're cooking the gas. All right, let's go back here. So what do I have? What have I done? What have I done? Oh, I just did short protocols. Okay. So network. I'm in the 10.1.1.4. Mask. 255, 255, 255, 252. All barrel. I'm also in the 8. And then network 2.2.2.2. Mask. 255.205.205.255. Cool. WR. Now, by doing these network commands, what we're doing is we're actually putting in entries. We're advertising prefixes or networks. So therefore, we're going to be getting prefix received, and then we'll be creating a local rib or your BGP table. Okay, which in turn populates your routing table. So we're going to router BGP 65300. BGP. Always put your router ID manually, please. 192.168.3.3. Didn't I do this? I already did this. What am I doing? Okay. I'm doing the network commands. Network, muscle memory. Network, okay, I'm on the 10.1.1.8 with the mask of 255, 255, 255, 252. And then we have our loopback, network, 3.3.3.3, mask, 255.255.255.255. Control Z, WR. And let me just do show protocols. I second guess myself all the time. Show protocols. Yeah, I'm good. Just want to make sure. All right, so now let's just do it from right here. Show IP BGP before we can get anything, right? On router 1. Now, we have networks, right? We have a BGP table, a local rib. All right, so let's just talk about briefly about this. These are the networks that you've learned about. And it's telling you these are the best valid path, right? Well, the asterisk means it's valid, and the greater than symbol means it's the best. Well, to get to this one, the 1.1.1 from router 3, you got to go through here, right? That's the best way to go. You got to go through 2 autonomous systems. You have no choice. All right? To go to 2.2.2.2, I got to go through 1 autonomous system because it's right here. The other one's right here. All right, here, 3.3.3.3, what does all zeros mean? You're connected. You're directly connected, okay? And it shows no autonomous system, but it shows a weight. The higher the weight, the better it is, all right? The faster it is. So this is the best valid path. So you see they're all different networks. That's why to get to these different networks, these are the best valid paths to get to them. That's it. It's a straight line. There's not much you can do here. All right, but understand, these right here are attributes. This is what's called your med, okay? Your metrics. Your local preference by default is 100. The weight, again, the higher the weight, the better. If it's 0, no good. But here we're not using the weight. Here we're using the autonomous system path length, which in order for me to get over here, I got to go through 65.200 and then go to 65.100, and then I make it to this guy right here. That's what this is saying, okay? And this is your origin code, which is right here. These are a little bit confusing, okay? Just so you understand that this means that it got there because you made network statements, pretty much, okay? That's what that means. No worries. It's not IGP because this is an eBGP, so it's kind of confusing. It's just because you made network statements. That's it. That's what this is. And if you look at the show IP BGP summary, now you see I've learned 4 prefixes. 4 prefixes. Right, so now you look, you sent 14 messages, or your neighbor has sent, you've received 14 messages, you sent 14 messages. Now the table version that you just got updated with is 8. And then you've been up for 8 minutes and 26 seconds, and you got 4 prefixes. So let's do the, see if we can ping. Let's just ping the loopbacks, 101.101.1. Cool, and then 2.2.2.2. So there you go. That's a very basic eBGP configuration. But I mean, we went to a little bit of the explanation, but not too deep into it. But there's a lot to BGP. There is a lot. It's very complex, and it's a lot of things you can do with BGP. All right. Just so you know, normally what people do is run BGP, whether it's normally it's on iBGP where they do this, where you just peer and then you run an IGP, meaning EIGRP, RIP, or you can even do static or OSPF or ISIS, and run an IGP and just peer with your BGP. You can do that as well. Okay. But there you go. Pretty simple. Practice this. You're gonna need this. You're gonna have it for your certifications, CCNPs, NARCI. All right, soon enough, the CCNA will be involved with this. And obviously, when you get to a workforce, this is going to be something that if you deal with an internet service provider, if that's your role in the company, you're going to have to know how to handle BGP. See you next time.